We talked about statistics, definition of concepts. Then we talked about the population, target population versus accessible population, sample, parametric parameter and statistic, qualitative data, variable, descriptive versus differential statistics, measurements, where we talked about the 4 types of measuring scales: nominal scale, ordinal scale, ratio scale, and interval scale. Then we talked about organizing data as one of the ways of managing data sets. We said that there are 2 ways of organizing, describing data. One being organizing the data, and the other one is being summarizing the data, which we are going to talk about today. And in terms of organizing the data, arranging it in frequency distributions, as well as presenting it in graphic form. Any constraints, questions, problems? I think we didn't talk about that. That was the last slide we should have talked about, but we never talked about it. When you present your data in graphic form, which is a very crucial part of statistics. When you have any data, you want to organize it using the frequency distributions, which will later help you to present the same data in graphic form. The importance of presenting the data in graphic form is that it helps you to describe a number of crucial things. In terms of the frequency polygons we talked about last time, the most commonly form of the frequency distribution is what we refer to as the normal distribution. Where is your friend?
She's coming.
Oh, she's coming. And when you are talking about a normal distribution, one assumes that every set of data should be normally distributed in the population. And a normal distribution has a shape. Mine is not a very clean normal distribution, but a shape where if you divide it into half, this can actually be the same as this other side. Where if you put it, these lines will fall on the same spot as a normal distribution. What this implies is that the majority of the cases are lying on the midline. The midline assumes the plateau of that distribution, the drop of that distribution. But the lower scores will be on the lower side, that side, and will be fewer. Most of the scores will be falling in the middle, and as we go to the highest scores will also be fewer. For example, if we had an exam for a class which has 150 students, and let's say the lowest score in that exam is 45, just for accuracy. So from 45 maybe to 55 will be a number of students who have scored that. But we expect those to be fewer. That's why on this side will be lower. And let's assume the highest score was 95. And among those the highest scoring students, maybe from 90 to 95, you expect them to be fewer here. But the average student scored 75% in that exam. You will find that most of the students scored around 75%. So between 70 to 80%, you might get the majority of the students scattered around there. That's what we refer to as the normal distribution. Or if, for example, you went out to collect data in terms of height of students at the University of Oyo, one would expect that the distribution of those heights will take this shape. So the short people, the shortest person will be on the lower side, and the short people will be around that side, and there will be fewer. The tallest person will be there, and the tall people will be here, but they will be fewer. The majority of the people will be medium height, so that's why in other normal circumstances, statistically, you find that most of the data you collect will assume a normal distribution, a bell-shaped curve. Okay? But sometimes you might find that the data is not normal, it has assumed that kind of shape. And what does this mean? It means that the majority of the cases there are some cases which are extremely lower than the majority of the cases. The majority of the cases will be around that because this is the big, right? But there are a few scores which are on the lower side, abnormally low. Let's say in the same case of our exam, you find that the lowest score is 25%. The majority of the people have scored very well, maybe between 80 and 90. And then there are a few who have scored above 90 on this side. But it means that there are a few people who scored extremely poor in this exam, below average. And they are pulling the kid this way. And when you have such a situation, we refer to this type of kid as a negative skew distribution. Sorry. Negative skew distribution. And it's called negative skewed because the extreme scores are pulling on the negative side of the game. But you will have a similar situation where the scores look like that. And that's the positive skewed distribution. Meaning that there were a few extreme performers, but the majority scored on the other side. Okay? So, when you are doing your analysis as a way of exploring how your data has behaved, you want to plot it in a graph, and plotting in the graph here, right? We are doing it manually, but in the computers, when you're going to do things like SPSS, SAS, it has the ways of plotting the graphs for you. So, for you to be able to describe the sort of distribution which you have. That makes sense? Yes. Okay. Are there any more students apart from you in this class?
Yes.
There's one more? Two more?
Yes.
Why are they not showing up?
Maybe speed challenge.
Oh, okay, they're not there.
Yes.
Okay. That's understandable.
Yeah.
Of course, I have noted also that people seem to be worried with this course.
Yeah. And you tell us something about it. Because some are even scared. Hi. This and that.
Yeah, but for this course,
Yeah.
I don't think it should be too scared. It is a mathematical course,
Yeah.
but my interest is not to worry with the mathematics. My interest is for you, when you analyze the data, to know what is happening in that data. So yeah, we'll be looking at various the equations and the like, but they are meant to help you understand what is happening in the analysis. Not to worry about the it's understandable. A lot of people are fear.
You just have to also reflect, right?
Eh?
You just hear that we also reflect.
You are the first group of people.
Yeah.
Okay. Yeah, I'm also new in this place. So, but don't worry. We'll make it user friendly. Yeah. So that we Because in most cases, the data will be analyzed in the computer. So the computers they have all the programs you can use, and they will do the calculations for you. So,
It would be as challenging as we think.
I don't think you should worry about how smart you are in calculating something. No. But when the computer has done it, you need to know what it has done and be able to explain what is happening. So, for example, as we're talking about this case, you need to be expected to talk about them. What is happening? If you are collecting the data, let's say income data, you need to explain, on average, the average income is this, or the mean income is this. The highest income is this, the lowest income is this. And the distribution of income in this society is a society where incomes are generally low in nature. When you are looking at it, a situation like that. So we say, well, the mean is this, but most of the people, their incomes are the lower side. Okay? So, this situation, say, although the mean income is low, it looks to be low, but quite a few of the people have high income people. And what does that imply? Things of that nature. So, that's what I'm expecting you to talk about. The income levels in this population are normally distributed. You are describing your data, you are describing your sample, you are describing your population. So, the computer gives you those things, you should be able to talk about that. Okay? Any questions about the normal distribution, skewed distribution, negative skewed, positive skewed? No questions, right? Things are okay. That's the case. Let's talk about something else. Last time we talked about the statistics. This is the integration of statistics. So now we are going to spend a bit of time talking about statistics, which is meant for describing your sample. And the purpose will be for you to be able to conduct statistics. Of course, as I've said, to know what happens in the computer is really easy. And in the descriptive statistics, there are measures of central tendency, which we require to talk about, with the measures of variability, which we need to talk about, and also talk about the standard scores, which will lead us into a description of correlation. basically what we're talking about in terms of these statistics. So we're going out to collect your data. Apart from organizing the data of things later on, frequency distribution, graphic presentations, one would expect you to conduct the descriptive statistics, which will be a springboard for you to go into the differential statistics that data. Differential statistics, the fact that you have collected the data from a sample and you want to give back to the whole population. So to do that, you need to do differential statistics. But first, before you do that, you need to describe what you found in the sample. Okay? So, in terms of measures of central tendency, it's a tool used for summarizing data. So, to summarize your data, you need to have at least a single score in that data, which will present the whole set of data. And that single score commonly used is what people talk about average. Of course, you as physicians don't just say average, because there are three types of average. As opposed to what you know. I know what you know is the sum of all the scores divided by the number of scores, and you call that average. That one is referred to as a mean. Or another name, arithmetic average. Yeah. So don't just say average, you say average. What kind of average are you talking about? Are you talking about the mean? Because there is also a mode, there is also a median, which you can use for describing averages. Okay? She got angry with me.
No, I was very hungry.
Oh, okay.
So they stand there and crushing everything.
Oh, you have just brought your food here and be eating what's no problem. Whilst you were away, we talked about the last slide, the whole slide, which I gave you. Where it talks about normal distribution, negatively skewed distribution, positively skewed distribution. So if you see these things here, if you plot your data into a graph, and the graph assumes this shape, which is referred to as L-shaped distribution. That's called normal distribution. L-shaped because the L is the shape of the L, yes, yeah. So, meaning that the majority of the scores are around the mean, There are very few schools on the higher side. There are very few schools on the lower side. In fact, this barrel-shaped distribution, you need to know it very well, because we'll be talking about it in class. But then there are sometimes when you plot your data and you find that the majority of the schools are there, but there are a few extreme schools on the lower side. Whilst on the higher side, the schools are showing a normal shape. If you have that situation, you're going to immediately to a skewed distribution. Sometimes you will have a situation where when you plot your data, there are a few extreme scores on the right. Yes, on the right, yes. But on the higher, which are on the higher side. And the majority are where the graph peaks. This is referred to as positive skewed distribution. That's what it is. So you found us now on a new set of slides where we are talking about the descriptive statistics. And as I was saying, when you have, as we were talking about last time, if you have a data set of income levels for 1,000 people, let's say you were conducting a survey in the area 15, and in area 15 you found 1,000 people. One of the variables you are looking at is income. So you ask each person to tell you what their income, monthly income, for example, is. Then you have 1,000 sets of data. If somebody says, what does this data say to you? It will be difficult to talk about it. So apart from organizing, as we talked about, another way of talking about that data is to summarize it. So we are talking about one of the summary statistics you use is the measures of central tendency, averages. And mark my way, I'm saying averages, because what you normally talk about as an average is not an average. The averages are many. That one is an arithmetic average or mean. You will find in the statistical people talk more about a mean, which is the sum of the scores divided by the number of scores. But as I was saying, there are three sets of averages. There is what we call the mode, the median, and the mean. So measure of central tendency was three types of them: mode, median, and mean. What people normally say average, they refer to the mean. And you as professionals now stop saying average, talk about it as a mean. But if you want to talk a common language, you can call it arithmetic average. The mode is the most frequently occurring value in a distribution. For example, we have those values 10, 9, 11, 12, 13, 11, 9. Now, by that definition, what is the mode 11? Why? Because there are 3 11s, only 2 10s, only 2 9s, only 1 12. So 11 is the most, because it's the most frequent way of carrying score in that institution. Of course, the mode has a problem. Sometimes you find that in one distribution there are 2 remote for example, in that distribution, what is the mode? 11 is the mode. 10
Yeah, 11, 10.
is the mode.
Yeah.
So now people say, so which is the mode? Because they are true. If you have an expression like that, it's called a bimodal distribution. Because it's true mode. It will be a modal distribution, it has 3 modes and that. But the fact that you can have such situations in your distribution, it makes the mode as a measure of central frequency which is not stable. It's an unstable measure of the central tendency. And people don't use it very frequently because of that weakness. However, if you have nominal data, then the only legitimate measure of average is a mode. You remember what we talked about nominal data? Mean. We say nominal data is the data where the numbers are only used as labels. If you are describing the distribution of crops in Njewa, so you have gone to Njewa area to study farmers, the farming activities that farmers are engaged in Njewa. And you find that they are growing maize, they are also growing tobacco, they are also growing groundnuts and cassava. So for you to be able to statistically analyze those, you would want to label maize as 1, tobacco 2, groundnuts 3, cassava 4. But 2 does not mean it's twice as much as 1. No, it's just a label. Okay? So when you have data of that nature, the only measure of average people expect you to talk about is the mode. Because if you find so many 1s, fewer 2s, fewer 3s, fewer 4s, it means the most commonly grown crop in the area is maize. Okay? If the lowest occurring number is 4, and you label the cassava as 4, it means the least grown crop in the area is cassava. So, when you are saying the most commonly grown crop, the least commonly grown crop, you are talking about mode. the most, especially when you say the most common road crop is maize, that is a mode. Okay?
Yeah.
So the mode is something you use to describe what you have found in your population. Making sense?
Yeah.
Okay? But as I said, you will find that most people don't use it. In fact, they use the lot before, but people don't like to use it as a mean, as an average, because of that problem of stability. But if you have just nominal data, yeah, let's assume 1 and 3 were the most common occurring numbers in that population. Then you say the most commonly grown crops are maize and groundnuts. Okay? So that's as much as we explain around those figures. Don't here, mathematics here. I was telling your friends that don't let your friends scare. Alright. We'll do the computation.
They don't have time regulation.
No, there are some calculations, but don't worry about those calculations. What I want you to know is what those calculations mean. Actually, in my exams, my assignments, I don't know what you do. But when I say describe the mode, describe the mode. How is it used? Where is it used? Where is it not supposed to be used? Because when you analyze your data in your computer, whether you're using SPSS, these things are what people are saying. And people will expect you to know about the second measure of central tendency is the median. And the median is the middle point in a distribution. A point where 50% of the cases lie low, or 50% of the cases lie above. That point is referred to as a median. And for you, look at that example I'm showing here. For you to come up with a median, you need to organize your data from the lowest to the highest. So, this demonstrates one important feature for the frequency distribution. So, you remember what I talked about? You do in frequency distributions, you arrange the numbers from the lowest to the highest and you count for each score. How many are they?
Yeah.
Yes. So when you do that, now you can be able to compute a median. Because the median will be the point where 50% of the scores lie below 6. So like in this one we have how many scores? 1, 2, 3, 11. So when you count 1, 2, 3, 4, 5, 6 is the middle point there. And that 6 score is 19. Right here. So this 19 exam, and then you arrange the performance from number 1 to the lowest. Then the one who is the score in the middle of the okay? This one is an easy one, eh?
Yeah.
Because we have an odd number of scores, 11. What if it was an even number of scores? What happens? This time, each score is considered to lie in a range between the lower limit and the upper limit of the score. For example, in this distribution which I'm showing here, let me use this one. 17 is considered to be lying within a range of 16.5, the midpoint between the lower score and the score, and 17.5, the middle point between the score and the next higher score. Okay? And that allows you to be able to compute the median. Because it's not at 17, because 17, these scores, which are 4, are, it's not at 18, because these scores here are not 50% of the scores. So according to our definition, at a point at which 50% of the scores lie below it fails to complete. That can only happen when you go in. Okay? So, because it is falling around there, then it is 18.5. So that's what happens when you have to and even number of scores. Okay?
However, previously we were saying it's impossible to find a median in that case, but now we have come to know that.
Yeah, that's how we compute the median. That's the way. So in other words, this 19 is falling between 18.5 and 19. Because this is also 19. This 19 is falling between 19 and 19. So 19. Okay? Questions? About media? No questions there. Clear. The point at which 50% of the scores lie below it. In terms of the characteristics of the media, it does not take into account the values of the individual scores. What I mean? If we went back to this example, if we're computing a mean, we would have said 14 plus 16 plus 16 plus 17 plus 18 plus 19 plus 19 plus 19 plus 21 plus 22. Divide by 11. Ah, 11, is that 11?
Yes.
Not 12.
12.
12. Yeah, that's why we have it. 1, 2, 3, 4, 5, 6, 7, 8, 9. No. 1,
10.
10.
Oh, 10.
Yeah, 10. 10. That's why we're having problem to find one single number in the distribution in the media, because it's falling between 5 and 5. Yeah. So you would have to sum those, divide by 10 to come up with a mean. But the media has not done that. When you are summing 14, you are taking the value of 14. Okay? Plus 16, you are taking the value of that 16. Plus 22, you are taking the value of that 22. But the media is not looking at that. It's just looking at the order in which the data has been presented. And because it is looking at the order, it is an ordinal statistic. Okay? You remember what we talked about the ordinal data?
The ordinal one, the one which numbers represent.
That one is nominal. Ordinal is where the numbers have been ordered from lowest to the highest.
The UN is probably order.
Yeah. Yeah?
And the keyword is only like from the order.
They are order. Yeah, order. The mode which we described earlier on is a nominal statistic, because currently used in nominal data. Okay? Questions? It's clear?
Yeah.
Okay. Then we can just finish discussion about the media. So we're saying the media does not take into account the value of individual scores. It's an ordinal statistic because it is based on the rank of the scores. First you have to order the scores so that you can find where each score is scoring. But whilst it is an ordinal statistic, if you were to use it in interval data or ratio data, it's okay. Let's say that this data is representing ages of students in a school. So the youngest student is 14 years old. The oldest student is 22 years old. So if it was 8, 14 has a value, 15 has a value, 17, 19 has a value. But still, you will order it in the way we have ordered and compute a media. Perfect. Recall that last time we said that if you can collect data in ratio or in interval, collect it that way. Because if you're looking at the ages, you could also have ranked it, say, the youngest person is 1, the oldest person is 10, right? Youngest person 1, so this one is 1, this one is 2, 3, 4, 5, 6, 7, 8, 9, 10. In terms of ordering, that's still an orderly scale, right? But if you rank it that way, if you collect the data that way, you cannot convert that data into their ages. You just be able to say this is the oldest, this is the youngest. Okay? When you have collected it like that, you can use it as ordinal data, you can use it even as nominal data, and you can use it as ratio data. Okay? Questions? No questions there?
Yeah.
But mark that thing I've said. If you are correcting the data, if you can correct it in ratio, data correcting in ratio. I'll give you an example where people change the ratio data into ordinary data. You are conducting a survey, and one of the variables you have to collect is the income levels. And you know very well that people are not happy to reveal their income. So you decide to say, okay, instead of asking them the exact income that they have, I'll ask you in what range of income do they belong. So you decide to organize your data in ranges. 500,000 to 800,000 kwacha per month. One, 800 and 1,000 kwacha to 11. 1,100,000 kwacha. That's okay. Yeah. It's 2. 1,100,000 and 1. 2. 1,400,000. This is 3. So you ask the people, say, in which range of income do you belong? Just because you are worried about them telling you their actual income. So what you'll be collecting is now not this. Of course you know that the one represents 500,000, 800,000. 2 represents 800,000 to 1.1 million. 3 represents 1.1 million to 1.4 million, and so on and so forth. But it will be difficult for you to convert this data back to that.
Yeah.
Okay? And when somebody says, what is the mean income? Even this will not give you the mean income. Okay? It will be difficult for you to calculate mean from that. So that's the portions I'm giving you. Because even in ages, if you go in the ages, people but there is a value in breaking the data like that. Okay? you are doing interval or ratio data, that is when you have situations like this. Okay? When you have skewed distributions. Because as you see later on, in a skewed distribution, the mean tends to be pulled by the extreme scores. So the mean will be either too low, the majority of the people have higher scores, or the mean will be too high, the majority of the people will have lower scores. So in such situations, you may want to report the mean, don't throw away the mean, report the mean, but also provide the median, so that people will know that we are dealing with a data which is not normally distributed. Okay? What I'm saying is, for example, if you had a data set which looks like that, if you were to compute it, I did compute a mean in that one, it's an straight mean, and the mean was a 62. Why? If you were maths, these two giants cause result. The majority of the students they formed between 49 and 57. But there were two giants who got 90, and the other one was too much a giant who got 99. And you put in the mean to the extreme score on this side. So in this situation. Okay? But you could also have had another situation putting the mean on that other side this situation.
Yeah.
So the mean, whilst being perfectly correct, would not be shown the typical performance in that distribution. So the median, which is the middle point, is more typical than the mean. Okay? Does that make sense?
So say after adding those numbers and divide by
1, 2, 3, 4, 5, 6, 7, 8, 9. Divide by 9.
the answer is 62.
62. You can try this just to check.
No, it's okay.
Maybe you can have 10 minutes. Okay.
However, I was saying the mean is 62, which is overestimated due to